Hello and welcome to my channel. Today we're going to cover kinetic energy. This video is linked to the previous video I uploaded about potential energy. So if you haven't seen that video yet, I would strongly recommend to go and watch it before watching this video. Okay, so to start, what is kinetic energy? Kinetic energy is the energy an object has due to its motion. This means that any moving object has kinetic energy. The faster it moves, the more kinetic energy it has. So the following formula is the one we're going to use, which is kinetic energy is equal to half mv squared. M stands for mass and v stands for final velocity. You should know this before starting with this topic. So let's consider the 1 kilogram suitcase on the table that we discussed earlier in the other video. When the suitcase falls, it will gain velocity because it's falling faster and faster until it reaches the ground with a maximum velocity. The suitcase will not have any kinetic energy when it's on top of the table because it's not moving. Once it starts to fall, it will gain kinetic energy because it gains velocity. Its kinetic energy will increase until it's a maximum where the suitcase reaches the ground. Okay? So basically what it means is that when an object is not moving, it has no kinetic energy. So as you can see here, the kinetic energy when the suitcase is on top of the table, the kinetic energy is a minimum. It has no kinetic energy, so 0 joules because it's not moving. When the object is just about to hit the ground or to stop, the kinetic energy is a maximum. As you can see here, when the suitcase falls, it will have a kinetic energy of 19.6 joules. Okay? So now that we're here, let's go with a problem. A stone with a mass of 100 grams is thrown up into the air. It has an initial velocity of 3 meters per second. Calculate its kinetic energy, okay, as it lifts the thrower hand. So we know the mass is equal to 100 grams, right? But 100 grams is not the unit we're looking for. We're looking for kilos. So we're going to have to transfer our grams into kilos. So it's going to be 1.1 kilograms. Okay, now we have mass. What else do we give? Well, the problem says it has an initial velocity of 3 meters per second. So initial velocity, 3 meters per second. So now that we have here, we write down the kinetic energy formula. It's a half mv squared. So half. So we write it down. It's a half. Mass. What's the mass? Well, we're given the mass is 0.1, and the velocity, which in this point, because it's the final velocity, okay, it says it has an initial velocity of 3 meters per second. So we wrote down u, but in the problem it says v. The thing is that when it leaves the thrower hand, just when it leaves it, it's going to be the initial velocity, but it's also going to be the final velocity of it, because we're not thinking about the rest, okay? So the final velocity is going to be 3 square, okay? So now we have this, we get that is 0.9, so this is going to be 0.45 joules. Always remember to put the unit. Okay, so this is going to be our result. So we've done part A. Let's go to part B. Calculate its kinetic energy when it reaches the turning point. Okay, so to do this, we're going to have to understand what the turning point is. Well, let's say this is our hand here, and we want to throw a stone. When we just throw it, the stone is going to go up, and then it's going to be a point when it's going to turn around and it's going to go down. Okay, what this is called is, because the gravity is pulling down through the earth by 9.8 meters per second square, the stone, there's going to be a point, it's going really quick here, and it's going to slow down until it reaches this point, and then it's going to start going down, okay? So at this point, if you think about it, that point, the velocity, that's the turning point. And at the turning point, the velocity is equal to 0 meters per second, because that's the point where it's not even going up, but it's not even going down. So it's just staying there for a couple of milliseconds, okay? So the velocity is going to be equal to 0 meters per second, okay? So the velocity is going to be 0 meters per second. The mass, as we said before, it was 0.1 kilograms, okay? I'll leave this here so we can see it later, okay? And that's what we need. So we have that the kinetic energy is equal to 1/2 mv square. So 1/2 the mass, which is 0.1 by 0 square. What happens here? Well, everything multiplied by 0, because everything here is multiplied by 0 here. So anything that's multiplied by 0 gives you 0. So the kinetic energy is going to be 0 joules. As we covered before, we said that if an object is not moving, then its kinetic energy is going to be 0 joules, okay? So that's the end of the video. I'm going to upload this into the description so you can see it if you want to. And I'll see you in the next video. Thank you.